Hello everybody, welcome back to Happy Little Diodes. Today we've got yet another Toastrack to look at. This time it's a straight up refurb and service, so we'll be taking a look through the various service modifications you might like to do on your Toastrack. This particular machine's been really well looked after. The keys are nice and white, it's been kept out of the sun, and it's not too dusty really. I mean, compare this to the last video, that's looking pretty good. Although that's not going to stop me fully disassembling the keyboard and the case and giving it all a good clean. The only minor problem I found is the felt is missing off this leg, but I've got spare legs so I'll pop a new one on in its place. Here's the serial number of the machine for anyone who's interested. And here are the machine's insides. It's a version 6U PCB as opposed to the earlier 6K PCB that we had in the previous video. The owner has complained of the return key not working. We can see it's an original membrane, simple job to replace that with a new one. The supports here are also in good condition, nothing broken, so nothing for us to replace there. Let's get this board out of the case. There should normally be 4 screws holding the PCB to the bottom half of the case. We also need to unplug the 7805 voltage regulator and remove the reset switch from its holder on the left hand side, then the thing should lift out. Lovely, so here's our naked PCB. We can see it has a toroid fitted in the top right, sometimes that's not there, not to worry if it isn't. And interestingly, if you did watch the last video, you'll remember that we had radial capacitors in these two places. We've got axial ones now, which makes me feel better about replacing them with axial caps. Our ULA was born in October of 1985. Here's a closer look at the toroid. It's kind of just been wrapped in there with the wire, not attached to the PCB, but I'm not going to change that, I don't think that's a problem. Now the owner of this machine would like to use it with his Opus Discovery drive. All I know about this thing is it's massive. It actually almost covers the RGB socket on the back of the Toastrack. So the special request is to perform a composite video mod on this, which is less common on the Toastrack than it is on the 48K machines. It's a slightly different process to what we're familiar with on this machine. We are going to need to connect a composite video signal to the RF socket like normal, but we're going to need to find that signal elsewhere on the board. As it happens, a composite signal which is suitable for this job can be found on the RGB DIN socket here on pin 1. Let's take a quick look at our schematic. Here's our DIN connector, the circular one there in the top left, and here's the path of the composite video signal from the TEA 2000 encoder chip. We can take our composite signal from this resistor. Now if we zoom out and look at the whole schematic, we can see our modulator on the right hand side. I'll put a little box around it, and we can see that the composite signal from the chip does find its way in there via a different path. We need to cut that and replace it with a wire coming from our resistor that we identified just a second ago. Looking at the underside of the PCB, underneath our DIN socket, we're going to be taking a wire from this area over to this joint, which is where the composite signal enters the RF modulator. Probing around a little bit, we can identify the joint from which we need to steal the signal. Alright, found it, it's this one. So let's get some wire. We need some thin wire, and we're going to solder at one end into this joint. Helps to clear the joint a little bit so you can see what space you've got to work with, and then melt the solder and poke the end of the wire, stripped obviously, into there, and then add a little bit extra solder to close up the joint around it. Okay, that's pretty neat. Now let's remove the inputs to our modulator so we can replace them. That's these 2 wires. We're just going to lift them out and fold them over the case. I'd rather not cut them, just in case in the future somebody wants to reverse this modification. If you have managed to resist cutting them, they'll be long enough to just fold over the side of the modulator casing. Now we need to remove this resistor from the socket. There we go. And with the joint on the left being clear, we can poke our new wire through, which is connected on the other end to pin 1 of the DIN socket, our composite video signal. Let's trim this wire down to just the right length to keep things neat, and solder it on to the RF socket. That's looking pretty good, nice connection there. Let's replace the lid make sure those two wires are tucked in neatly, and we can give it a test run. Feels a bit weird to be running a Toastrack without an RGB cable, but here we go. Hey, it worked, brilliant. Doesn't look too bad actually. We are going to clean this picture up with a couple more mods later, but for now I'm glad that's worked first time. Right, what's going on here? I've got the RGB hooked up this time so I can record a nice picture. Got the dandinator plugged in with the joystick so I can browse the menus, because I want to give you a demonstration of the sound that comes out of this thing via the AY chip. So what we're going to do is we're going to run Dizzy and listen to this chip in all its glory. The reason I'm showing you this is because along with the AY chip, the Toastrack can also give you sounds from the buzzer, like you're familiar with from the 48K. And that sounds something like this. When we use a SCART cable with our Toastrack, the audio levels from the buzzer and from the AY chip are quite out of balance, as you'll see in this little demonstration here. Compare the volume of the low-level hum you're hearing from the AY chip with the beep that you're about to hear from the buzzer. Pretty unpleasant, I'd say, so let's do a mod to address that. What we'll do is replace the 10K resistor R115 with a new resistor value 1.65K. There it is, nice and blue. Now we can run that same code again and listen to the volume difference. So remember, we have the low level hum from the AY chip compared to the beep sound. Much more balanced in my opinion. Alright, next mod, let's go. Look at the jail bars in the background of this menu screen. You don't see these as much on the composite signal, but they're really clear to see on this RGB signal. So there's a mod we can do to address that too. What we'll do is replace C7 and C8 22 microfarad capacitors with 1 microfarad capacitors, and we'll replace C28, which is a 22 microfarad electrolytic, with a 47 microfarad cap. And let's have a quick before and after. So here we have before the mod, jail bars looking pretty clear, and after the mod, jail bars nowhere to be seen. Now that's all well and good, but take a look at our composite output again. I can see some jail bars now. That's not too good, they weren't there before. So I can only conclude that the jail bar fix does improve things for the SCART RGB signal, but not for the composite signal. It makes things worse. So I actually undid the mod, because the owner wants to use composite signal and look how much better it is. It seems a bit of a shame, but that's the way it is. Okay, what's next? Have a close look at the composite video output here. Do you see a shadow, like a yellow shadow? I definitely do, and there's a mod we can do to fix that too. This modification is based around the TEA2000 video encoder chip. I recommend looking up Joules per Coulomb on YouTube. His video on this particular mod goes into quite a lot of detail and explains it very well. I'm just going to tell you what to do. What we're going to do is add an LC filter, that is an inductor and a capacitor filter, to the luminescence input to the encoder chip. This effectively removes noise from the input on pin 8 and improves our problem with the yellow shadows. It's a bit of a DIY mod, this one. There are two ways to do it. You can try and achieve it on the underside of the board, or you can kind of bridge over pins 8 and 17 using the components, as I'm going to do. So I've got this 15 microhenry inductor and an 82 picofarad capacitor. I'm going to connect them in series, cutting the legs nice and short so they bridge neatly over our chip. I've decided to try and connect the two components first and then solder it to the chip, rather than soldering them individually to the chip's legs and joining them over the top. Okay, here's our LC filter. Let's get the board back in the picture. I've stuck a little blue tack sausage on top of the chip, which will help me keep the components in place while I make the connections. Through the magic of video editing, I'm going to make it look like I nailed this in one. That's the inductor connected to pin 8, and the capacitor to pin 17. Lovely, let's clean up that blue tack and we can give it a try. We'll go with a before and after like we have been doing. Here's the before, notice the yellow shadow on the right hand side. And here's after, it looks quite a lot better if you ask me. Let's see that one more time to save you rewinding. Before and after. Now I have learned of one more mod we can do to improve this video signal. Looking at the schematic, we can see that there's an audio signal mixed in with the inputs to our video encoder chip. This mixes an audio signal into the RF output, but that doesn't help us because we've disconnected that and put composite video in its place. So we can remove this unnecessary extra noise. We're going to follow the mod as described by Ben at Byte Delight. We disconnect the audio signal and feed it to the emitter of the transistor here before the video output. This won't affect anything at the modulator end. Remember, we disconnected that video input and replaced it with a composite signal. Doing this means that the RF signal will have audio if it is reconnected in the future, and the composite signal won't be noisy. The mod happens up here in the top left of the board. We're going to disconnect the right hand side of this capacitor and follow the instructions like you can see in the picture here. Okay, let's do before and after. This time I've got the before on the left and the after on the right. Now from this distance I can't really see much difference. What do you think? Tell you what, let's zoom in a bit for a closer look. Yeah, okay, I think I can see that the picture on the right is a bit more sharp. Let's zoom in again. Yeah, okay, I'm pretty convinced now, the picture on the right is better. I promised I'd clean this thing up as well, and I have done that. I won't bore you with footage of me washing keys, but it's done now. Let's put everything back together, starting with the bubble mat, our shiny new keyboard membrane. Lovely. The backplate, this is a plastic one, they can be metal, that's the wrong way around, there we go. We mustn't forget the keyboard ribbon clamps. As I mentioned earlier, 4 screws into the motherboard. We'll reconnect the heatsink, which has also been cleaned. This is held in by 2 screws, and then we need to plug in the voltage regulator again, being careful to plug the connector on the right way around. Lovely, we're almost there. The reset switch has been replaced on the left side of the case. Don't forget to put that in, it's really annoying having to undo all the screws again. And now what about this leg? I said I'd replace it with one with some felt on. I found a good replacement, looks like a match to me, so let's get it built up. Cool, this has been an interesting job, I've learned a lot. I haven't refurbished many of these because I guess there's just not that many of them kicking around. But it's cool to do mods that have such a significant effect on the quality of your video and your sound. This has been a pleasure to work on because it's such a well preserved machine, and I'm definitely looking forward to working on more in the future. So with that said, let me know if you want yours looking at. I'm going to put this through its paces with some diagnostic tests and get it back to the owner. Thanks everyone for watching, please like and subscribe.